In this video, we would cover various pandas operations like sorting the data frame, merging the data frame, or aggregating the dataset using pandas. So all those details would be covered in this video. This is the second part in the pandas video. So if you haven't seen the first video, make sure that you see that first before coming to this one. Hi, my name is Rohit and let's get started with pandas section 2. So let's import pandas package using import pandas as PD. So PD is just the alias or the short form that we would use for referring to a pandas package. Then we can read data from CSV using read CSV function in pandas. So pd.read CSV, and then here we are passing the name of CSV file which is stored at the same location where we have this Jupyter notebook. Then using this function we are able to read data from CSV into our data frame which we are calling as data. Then we have a head function in pandas which we can use for getting the data of top n rows. So to this head function we are passing value 10. So this would give us top 10 rows in data frame data. So this is how we can get the top 10 rows in data frame data. So in this data frame we have various columns like price, area, bedrooms, bathrooms. Now let's see how we can use this data and pandas to do the data processing and data manipulation operations. So we would start with data aggregation. Now suppose you have got the data of this housing prices, right, where we have information about how many bedrooms or bathrooms this particular house has, what's its price, whether it is furnished or unfurnished, how many parkings are there, is there air conditioning. So we have all these data points. Now you have been asked that tell me average price of house based on bedrooms. So for one bedroom house, what is the average price? For two bedroom house, what is the average price? Then to answer those questions, right, you can use simple data aggregation in pandas. So for that you can use group by function. So name of data frame dot group by, and to it you are passing the name of column based on which you want to do the aggregation. So in this case we want to do aggregation based on bedrooms columns. So by bedrooms, and then in square bracket you have to specify the column name on which you want to apply aggregation operation. So in this case we want to apply average or mean operation on column price. So price dot mean. So what this would give us is the number of bedrooms and corresponding mean or average price. So one bedroom house, this is the average price. For two bedroom house, this is the average price. So in general, if you see here, as the number of bedrooms are increasing, the price of house is increasing as well. We can also do the aggregation by using multiple columns. So for example, you want to do aggregation using bedrooms, but you want to get mean value of price as well as number of stories. So in that case, you can pass both the column names over here. So data dot group by, then group by using bedrooms column and apply aggregation on price and stories. So on price and stories, we are applying the mean function. So for one bedroom house, this is the average price and these are the average number of stories. For two bedroom house, this is the average price and this is the average number of stories. So this is how we can apply the aggregate operation on multiple columns using pandas. Then it might happen that you want to group by multiple columns, right, and then apply the aggregation. So in this case, suppose you want to aggregate using bedrooms as well as bathrooms and then find the average price. Then you have to pass the name of those columns into this group by function in the form of list, and then here we are saying that okay, calculate the average price of based on the column price over here. So here you can see what we are getting: bedrooms, bathrooms. So for one bedroom and one bathroom, this is the average price. Then for two bedroom, one bathroom, this is the average price. Two bedrooms, two bathroom, this is the average price. So this is how we are able to use group by function and group the data or aggregate the data using multiple columns and calculate the aggregated value based on the price column. So like we are calculating mean value here, we can also calculate the median value. So instead of mean, we just have to call a median function and that would give us the median value based on the group by operation which we are doing over here. And we can also use other functions like mean, max to get minimum value, maximum value. So based on the requirement you have, you can use the specific function to perform the aggregation and calculations. Now let's see how we can sort the data using pandas, because you might get requirement where you want to sort the data based on specific column or multiple columns. So let's see how you can do that. So in Pandas, there is a function called as sort values, which can be used for sorting the data. So by default, the sorting would be in ascending order. So suppose we want to sort all the data frame using the price column, and we want to sort it from low to high, that is in the ascending order. Then we can simply call sort values function on top of the data frame, and then we have to pass a parameter by is equal to price. So sort it using price column. So that would sort our data frame using price column. And as you can see here, the price column, we are getting now values from small value to the higher value. It is now sorted. The data frame is sorted now using the price column. And that is why we are seeing the indexes now getting changed. For sorting the data frame in descending order, right, what we can do is when we call the sort values function, we just have to pass it a ascending parameter. So you're calling sort values function, then you are saying that, okay, I want to sort by price column and ascending equal to false. So what this tells Pandas is that it has to sort in descending order. So if you do this, you would get the data sorted in descending order, where we have high value at the top, then the value after it. So this is sorting our data frame in descending order with respect to the price column. So this is how you can do the descending sorting operation using sort values function in Pandas. So here if you see, right, whenever we are calling a function, right, and then passing it specific values, after sorting we are again reassigning values, or after sorting we are again reassigning the data frame to our data frame data. So if you don't want to do this operation, and instead after doing this only update our original data frame, so in that case you can use in place is equal to true parameter. So when you pass this parameter to a Pandas function, it tells Pandas that after doing this sorting operation, just update the original data frame as well. So that's why then we don't have to do the operation like we are doing here, data is equal to our sorting operation. So what this does is, like, after sorting, it updates the data into our data frame data. But here, as we are passing in place is equal to true, after sorting, automatically the value in our original data frame would be updated. So if you do this and then print the top n rows using head function, you can see here that we are getting a data here, which is sorted. As we are not passing any parameter to it, it is sorted in the ascending order, low value to high value. Then when you are working on a Pandas data frame, right, you might want to change some values in a column, right, or want to do some operations on all the values in certain column. In that case, you can use a lambda function. So using lambda function, you can get things done much faster. So what you are doing here is, basically, suppose you have a guest room column, right, and in guest room you have values in the form of, say, text. So guest room no, there are 448 rows where guest room value is no, and there are 97 rows where guest room value is yes. So we are getting these values using the value counts function in Pandas. So on guest room, if you apply value counts function, you would be able to see the unique values and their specific count. Now in this, if you want to convert this no and yes into numbers, right, so you can get that done using the lambda function. So how to do that? Data guest room, so name of column on which you want to apply lambda function, dot, then use function apply, and then within apply you have to use keyword lambda. Lambda x should be set to 0 if x is equal to no, else it should be set to 1. So here x refers value in every row in guest room column. So at any row, if the value of x or the value at that particular row for column guest room is equal to no, then our apply and lambda functionality would set that to 0, else it would set it to 1. So yes would be replaced by 1 and no would be replaced by 0. So that's why when we do this operation, and after that if we apply the value counts function on guest room column, you can see here now we have 448 zeros and 97 ones, because we replaced no with 0 and yes with 1. So this is how we can use Lambda functionality to change the values of all rows in particular column based on the condition that we are specifying over here. Then we can also apply Lambda function on multiple columns. Now suppose we want to apply it on guest room and main road, both the columns, right? Then what we can do is we can call the apply function, and in that again lambda x is again the value at that particular row. So we are setting that value to yes. We are creating a new column here. Basically we are creating a new column to which we are going to assign the values which you are getting from the output of this row. So we are creating a new column and we are assigning it value yes at that particular row if x guest room is equal to 1, if the value at a row in column guest room is equal to 1 and value at a row in column main road is equal to yes. If these both the conditions are true, then we are assigning value yes, else we are assigning value no. So if we do this and we create a new column, then we can see that in new column we are getting no and yes based on this conditions which we have specified. So this is how you can also apply Lambda function on multiple columns. Only difference here is, as here we were applying only on single column, right? We can specify directly that whether x is no or yes and the condition for it or the output of it. But here as we are applying Lambda function on two columns, when we refer x and want to compare its value, we should also specify the column name. So x guest room and x main road, to make sure that this comparison is happening for the right column as we are applying it on the multiple columns. Then we can also merge two data frames using pandas. So before we do that, let's create two data frames. So we are creating a data frame df1 and we are creating it using data frame function using pandas pd.dataframe, and to it we are passing the values. So we are passing values in the dictionary format. So in this dictionary we have two keys, name and weight, and both the dictionaries have respective values. So name in this dictionary the key name has 4 values and key weight has 4 values as well. And then based on this we are creating a data frame. So this is how our data frame would look like. Then similarly we are creating a second data frame df2, and to it also we are passing a dictionary, and this dictionary also has 2 keys. Now it has name and height. So this is how we have created 2 data frames by converting a dictionary to pandas data frame using pd.dataframe function. Now suppose you have these 2 data frames, right? So the first data frame has name and weight of a person, and the second data frame has name and height of a person. And now suppose you want to merge these 2 data frames, right, based on the unique column which is name over here. So you can do that using a merge function in pandas. So for that you have to pass the name of first data frame, so in this case df1, and to this data frame you want to merge data frame df2. So that's why df1.merge, merge is the function, and to it your first parameter is the second data frame which you want to merge, which in this case is df2, and on which column you want to do the merging operation, because there needs to be one column which is common, right, based on which you can merge. So in this case it is name. So you can just pass the parameter on name, and then if you do this you can see that these 2 data frames are merged now, and we have an overall data frame df1 which has 3 columns, name, weight and height. So this is how we are able to merge 2 data frames using the merge function in pandas. Now let's assume that in your 2 data frames, right, again we are creating 2 data frames df1 with name and weight column, name and weight column, and we are creating a second data frame df2, and instead of name it has column username and height. So if you have a case like this, right, where you have common values in the rows but the names are actually different, right, what you can do is you can still do this merging operation. Only thing that would change while calling a merge function is how you pass the parameters. So here df1.merge, so we want to merge to df1, then which data frame we want to merge, df2, so that has to be passed. Then instead of just passing on, which we were doing over here, right, because both the data frames had column with the same name on which we can do the merge operation. But in this case, that's not the case. First data frame has column with name and second one is having name as username. So in that, instead of using on, you have to use left on and right on parameters. So left on name. So it means in df1, you should check for a column name, and right on username. So right on means the second data frame. So in that, you should check the column username. So in df2, you should check the column username for merging. And when the merging happens, it would happen based on similar values in these two columns. So if you see here, after doing the merging operation, we are having all the columns name, weight, username and height, and the merging happened based on the specific values. So for example, here for Rohit, the weight is 67 and for Rohit, the height is 167. So obviously after merging, we are getting a single row where we have all the data related to Rohit with weight and height. Now, as the column names were different in both the data frames, we are getting both the column names over here, name as well as username after the merging operation. Then we can also do the concatenation operation on pandas data frame. So if we instead of joining or merging, right, if we simply want to concat the data frames, so basically increase like concat the data frames along rows or along columns, we can do that using the concat function in pandas. So here I am just creating two data frames again, data frame df1 and data frame df2, like we created in above examples. So we have two data frames which have column name and weight, and the second data frame which has again column name and height. And now suppose we want to concat these two data frames, right? So what we can do is we can use concat function within pandas. So if you do pd.concat, then to that you have to pass list of all data frames, right? So we have to pass data frames in the form of list, because these square brackets indicate list. So first data frame df1, second data frame df2. Then you have to pass it axis value. So by default, the axis value would be equal to 0, and it basically would join two data frames vertically. So you would place a second data frame below the first data frame. So this is how the concatenation happens if the axis value is equal to 0. So in this case, if you see here, as axis value is equal to 0, we have a first data frame and we are placing a second data frame below it. So this is how basically the joining operation or concatenation operation is happening. And the height column was not present in first data frame, right? That's why we are getting nan values for height over here. And the weight column was not present in the second data frame. That's why we are getting nan values for weight column in the second data frame, which we concatenated. And then if we set ignore index equal to true when doing this concatenation operation, it would reset the index of a new data frame which is getting created, because the indexes were same in both the data frames, like 0 to 3, 0 to 3. But as we are doing ignore index equal to true, it is resetting the indexes from 0 to number of rows. So 0 to 7. So like we did this vertical concatenation, we can also do the horizontal concatenation using the concat function. Only difference that you have to do here is instead of axis equal to 0, you have to pass axis equal to 1. So that would create a horizontal concatenation between two data frames. So these are the two data frames which we have, and if we concat them using a concat function and pass axis equal to 1, it would create a horizontal concatenation. So if you see here, we are able to get now all the values concatenated horizontally. Two data frames are concatenated horizontally now using axis is equal to 1. That's it for today. In the next video, we would cover some programming questions related to the pandas. Because as we are following throughout the series, after every theory topic, we are doing problem solving section. Because at the end, it's important to develop your problem solving skills as well. Because those skills will help you when you're actually working on any project or when you're going for any interviews. So it's important to solve some problems. So in the next video, we will do that. Thanks for watching the video, and I will see you in the next video.